Our next scientist is a very interesting scientist by the name of John Dalton. He was an English chemist and was studying gases. And although I would love to delve into his work, what's most important about John Dalton is his theory about atoms. He basically takes this idea of atomos and puts it into a more modern light, bringing in more scientific principles into what we now call the atom. So he is actually credited with terming the word atom. Now, notice the date here. We jump from 400 BC to 1800. And there's actually a pretty specific reason as to why there was that length of time. Think about some of the periods of time in history that may have happened in between there, such as, like, I don't know, the fall of the Roman Empire, where we lost a whole bunch of knowledge. We launched ourselves into the Dark Ages, and it took us a while to kind of bounce back from that through the Renaissance and now the Enlightenment, period of Enlightenment. And that's kind of where we are right now. So through his work with gases, where in a weird time, they didn't even really understand if gases were made of stuff at all. They kind of didn't really think that there was anything there in the first place. He started to develop the rules of what qualifies as an atom and sets it out and actually publishes it. And that's why he is so well known. So his first big idea is that all matter is actually made of indivisible particles called atoms. Now, doesn't that sound familiar? That actually sounds a lot like atomos. But remember now, he's a new modern scientist, so this is a big new idea. He also said, though, that atoms of a particular element are all the same, and conversely, atoms of different elements have to be also different. Now, he wasn't exactly sure of how. He kind of theorized that this might be by mass, by size, maybe even color, but it wasn't super duper specific at this point. We didn't have enough knowledge yet. He went even further that said that atoms can actually combine in defined ratios to form compounds. So, for example, one carbon and two oxygens will always make carbon dioxide, but one carbon and one oxygen makes carbon monoxide. And if you have any experience with those two gases, you do realize they are two very different things. Neither much is really good for humans, but one is definitely poisonous. And one more big idea he kind of developed was that this idea that chemical reactions are rearrangements of those atoms. That actually drives the whole pursuit of chemistry forward. That without the rearrangement of atoms, there basically isn't really a chemistry. So we take these ideas, and now he needs to present an actual physical model of what he has in his head. And don't laugh, but this is kind of what it looks like. Doesn't it look like atomos to you? I know. It's basically the same thing, but what makes this one unique is all of the different rules and regulations that come into this. And based upon that, scientists start to have a field day, and we start to see dramatic sweeping changes in our atomic history. So just like we did before, I'd like to put him in historical perspective on a timeline. So now at this point, we have two major players. We have Democritus around 400 BC with the idea of atomos, and just a small ball of matter. And then fast forward to the early 1800s with the work of John Dalton. He comes up with a modern atomic theory, coming up with the rules of what makes an atom an atom. And that, again, atoms of different elements are going to look a little different by size, by mass, by color. We're not really quite sure yet. But the next couple of scientists start to become a little bit more sure about what really makes an atom tick.